Welcome to my channel Quest Physics students. In this class we are going to learn about the center of mass. Actually we are entering into the topic of system of particles, where you will learn about the moment of inertia and others, and it is the beginning of the system of particles. We call it as the center of mass. First of all, we have to understand what is the center of mass is. Center of mass, it can be defined like this, is the point where the entire mass of the body is supposed to be concentrated. It seems like the center of gravity, but a slight difference between the two. Actually, it's the major. Generally, we define the center of gravity as it is the point in a body. Listen to my words, I'm stressing here. Is a point in a body where the entire weight of the body is concentrated. Okay, I'm stressing the word, students. Is the point where the entire weight of the body is concentrated. Means what? Center of gravity is present in the mass of the body. But the center of mass, what I told, is the point where the entire mass of the body is supposed to be concentrated. Supposed to be means what? It may be in the body, that means what? In the mass, or out of mass. Okay, students, it may be inside the body, that means inside the mass of the body, or it is outside of the mass of the body. That's the major difference between the two. Then how these things are related? They are related. If you take the bodies have the different shapes, isn't it? Some are regular shaped and some are irregular. Generally what goes on? The center of mass of a body coincides with the center of gravity when the body is regular shaped. Means what? Regularly shaped, like a triangle, a rectangle, or a square, or a cuboid, or a cone. For all these structures, center of mass coincides with the center of gravity. Okay, students, center of mass is the point where the entire mass of the body is supposed to be concentrated. Supposed to be. It means there is no need of center of mass to be present in the mass. Okay, let's take few examples of center of mass. Okay, students, see. First we are starting with a triangular shaped plate. Okay, students, it's the plate which has a particular thickness. Okay, students. Okay. And we have to locate the center of mass and as well as the center of gravity. Center of mass is written as com, and some people like me, they write it as the same. It has both. What's that? It suits for both. Here, drop a normal from one of the vertices. Okay, and one more. And here, we join the diagonals. That means what? These lines which are drawn from the vertices, they are meeting at a particular point. Mathematically, we call it as a centroid. Okay, is a triangular plate. It is triangular plate, students. Okay, center of mass situated at the geometrical center. Okay, is a regular shaped body, so center of mass coincides with center of gravity. That means this position is both for center of mass and center of gravity, students. I told you center of gravity is the point where the entire weight of the body is supposed to be concentrated. Is concentrated. Okay, here the question will arise. Why would we choose the center of mass. Actually, does it exist? Actually, it doesn't exist. You can understand this thing very easily. Here, I am taking a box. Okay, it's a box. Okay, I am holding it. Means what? I am applying the force on the different positions of the body. See this? See the downwards. Here, 5 fingers of mine are balancing this body. If I remove one of that, it get balanced. Now I am removing one. That means it is tilting. Okay. Here, if I put all the fingers together at a particular point, then I am able to hold this. This point where I am able to hold the entire body is the center of mass. Actually, inside the box I have some weights in. That's why it is tilting. Okay, students. It is the empty. You can understand the thing very easily. See, I am holding now. Okay. If I bring all the fingers together, I can able, or I can hold in this way. It's a point where all the fingers are meeting and making the body in rest. See? See? Okay. And you have to remember one thing here. If you apply the force on the center of mass of the body undergoes uniform motion. Remember this sentence words. The body undergoes uniform motion when external force acts on the center of mass. That's why whenever we draw the free body diagrams, we choose the midpoint and we locate the center of mass. From there only we take the line of the force. I hope you are understanding what is meant by the center of mass. See, instead of applying the forces at all places, we are applying the force at a single point and we are making the body to move. Okay, students. Okay, it is the center of mass. Let's come to the topic again. It is the regular shaped body. I said it is the triangular lamina, where the center of mass is coinciding with the center of gravity. Let's see. We take one more body. It looks same. Okay, but it's not. Here I am taking a triangular frame, students. It is the frame. Means what? Mass is at the edges only. This is the mass. Okay. This is the hollow part. Even though it is hollow, the center of mass will be present at its geometrical center. Friends, if you watch it carefully, you will find the center of mass and center of mass is present here. It is center of mass, but I can't say the center of gravity is situated here only. It is not, because center of gravity always be present inside the mass only. There's a major difference between the two. Actually, this center of mass concept was developed to understand the motion of the body. Okay, by using the forces acting on it. It is the imaginary point. That's why I said the point where the entire mass of the body is supposed to be concentrated. Let's take one more set. This time I am taking a square plate. It is the square plate, students. Let's see where the center of mass is. Join the diagonals. These are the diagonals, and it is the plate. Okay, it is a plate. It is a square plate. Okay, students. It is center of gravity and as well as the center of mass. In the same way, if you take the same plate, it's looking like the plate, but actually it is the frame. Then see, if you draw the diagonals, then they intersect at a particular point. It is the center of mass, but center of gravity will be present anywhere in the mass only. Okay, students? In the same way, if you take a solid circular plate, okay, it's a circular plate, and its geometrical center is the center of gravity and center of mass. Okay, it's a solid circular plate. In the same way, if you go with a ring, it is a ring. Here is the classic example. It's a ring. In this case, center of mass is present at the geometrical center. It's center where there is no mass is situated, but center of gravity is somewhere inside. I'm trying to define what is the center of masses. If you go with different laminas, different shapes, okay, center of gravity coincides with the center of mass for regular shaped bodies. Okay, students, here in these cases, center of mass doesn't coincide with the center of gravity. Okay, and the definition is what? There is no need of, definition is telling us there is no need of center of mass to be present in the mass only. Okay, students, and you have to remember one thing: when two bodies are taken as a system and the bodies have the same what's the different masses, the center of mass always shifts towards the heavier mass. Do remember that. And if you apply the force and the system at its center of mass, the body undergoes uniform motion. Okay, students, let's know how to find out the center of mass of two particle system. Okay, thereafter we will find the coordinates of center of mass in a three-dimensional plane. Listen my words, students. Let's say it is the a coordinate axis system, and we are calling it as X, and obviously it is the y-axis as the origin. Okay, students, let's say a particle or a body is kept at a particular distance from the origin and it has a mass of m1, students. Okay, students, then we take one more body. Okay, students, it is another body which has a mass of m2. Okay, students, now see the location of center of mass of the body, or the distance I am taking, it is locating of the center of mass, and the distance of the center of mass of this body from the origin is x1. Okay, students, and the distance between the center to this x2, students. Okay, students, and see, now listen my words carefully. Center of mass is the point where the entire mass of the body is supposed to be concentrated, I said. That means what? There is no need of center of mass to be present inside the body. Are you following me, students? There is no need of center of mass to be present inside the body. And also you have to remember one more thing. The center of mass is always shifted towards the heavier mass and body, students. If you take a system of the bodies. Here we are taking the two bodies. If one has the more mass and one got the lesser mass when compared to the first one, center of mass always shifts towards the heavier mass. Here in this case, just say M1 and M2, and M1 is greater than M2. Just imagine, its size is much bigger than the second body. Okay, students. Then obviously the center of mass shifts towards the heavier one, I said. Let's say it is XCM and its location is this. We call it as the XCM. Okay, students. See, the XCM, that is the center of mass of the body, is not at all in the mass. These two are the individual and they are behaving like a system, and it is not at all in the mass in this diagram. Maybe depending upon the size and as well as the positions, the center of mass may lie in the body or may not. Okay, students, it is the M1 and we call it as the M2, and it is the center of mass which is lying here. Here it is. Now we are locating the positions of the bodies with respect to center of mass. Let's say it is the D1, the distance of the center of mass of the system from the first body is equal to D1, and obviously it is D2. Okay, students, it's the D1 and D2, and we have to find out, okay, D1 and D2 with respect to X1 and X2, students. Before doing that, we have to learn some useful relation, useful material to find out the center of mass. What is this? Here you know about the moment, students. Moment of force and as well as the moment of couple. When we are talking about the moment of force, we said that the moment of force, it is torque, I am saying, force multiplied with the perpendicular distance. Torque acting on a body is constant. In the same way, to find the center of mass of the bodies, we have to find out moments of the mass, students. Listen my words carefully. Moments of the mass, students. Actually, the moment of mass can be written as m into d. Okay, students. Okay, m into d is equal to constant. Okay, students. The actual relation is what? Mass is inversely proportional to the location of the center of mass from the center of the mass. Okay, students. Here it can be written as m1 d1 is equal to m2 d2. Okay, students. m1 d1 is equal to m2 d2. So on is equal to constant. We need to find the d1, students. If you watch this diagram carefully, from here to here it is xcm, okay, and it is x1. If you subtract this x1 from xcm, you will get d1. That is d1 is equal to xcm minus x1. Okay, students. In the same way, we need to find d2. Here x2 minus xcm is equal to d2. d2 is equal to x2. It is the x2 and it is xcm. Okay, students. Here C means center of mass. I'm just putting the values in. Let's see what happens. m1 instead of d1, I'm writing it as xcm minus x1. is equal to m2 of x2 minus xm. Okay students, it can also be written as m1 xm minus m1 x1 is equal to m2 x2 minus m2 xm. Okay, and it can also be written as m1 xm plus m2 xm, I'm bringing here, is equal to m1 x1 plus m2 x2, and we need to find the xcm, xcom or xcm or xcom. What to get? m1 x1 plus m2 x2 upon m1 plus m2. Okay students, it is the expression for the center of mass of a two body system, students. And what we got? See, I am writing here xcom is equal to m1 x1 plus m2 x2 by m1 plus m2 is the equation for the center of mass. Okay students, let's do one of the applications, students. Here see, I told you, okay, the product of mass and the distance remains constant. That means what? We are taking the moments of the mass. According to that, mass is inversely proportional to the position of the particle, that means from center of mass. We wrote it as the m1 d1 is equal to m2 d2 is equal to so on is equal to constant. Here we are taking a two body system, that's why we did. Then after we have to locate the distances d1 and d2 respectively, and we got it is xm minus x1, and substituting we get, okay students, xm is equal to m1 x1 plus m2 x2 by m1 plus m2. We are going further, students. Here now we are going to change the axis. Here already we got the relation there for the center of mass, and we are doing one of the applications of this. See the students, let's say it is the same axis system. I said it is m1 and it is m2. Here I am keeping the first body, okay students, and the second body it is, okay students. We have to locate the center of mass. Obviously it will be at higher mass. We said it is xm. Okay, it is near to the bigger one, I said. Here we are using the same relation to find out the center of mass. You know that xm is equal to m1 x1 plus m2 x2 by m1 plus m2. Let's say this is x2, okay students, and x1 obviously it is equal to 0 since it is kept at the origin and the center of mass is lying at the origin. Then immediately we can write xm is equal to m1 multiplied with the 0 plus m2 into x2 by m1 plus m2. Okay students, then it can be written as m2 x2 by m1 plus m2 is the location of the center of mass. Let's say x2 is equal to L, then it can be written as, and m1 okay is equal to m, and m2 also we are taking m, and what we get? Take it as m2 only, m2 L by m1 plus m2. Okay students, okay, see this, and we are taking one more example. See, we are locating the center of mass with respect to second body. I am doing the same thing, but I am changing the axis now. Okay students, it is m2 and here it is m1. The distance is here. Okay, students, we have to apply the same relation. Xm is equal to m1 x1 plus m2 x2 by m1 plus m2. Okay, students, that is Xm. It is at the heavier mass we said, so it is Xm. Then what you get? Xm, we get the value here m1 x1 plus m2. It is at the origin, that is x2 is equal to 0 into 0 by m1 plus m2. That is Xm is equal to m1 L by m1 plus m2. Okay, students, these are the few examples of center of mass. And now say, what is that? If the masses are same, where would be the center of mass? Okay, students, here what I am saying, it is m1, say it is m, and it is m2, it is m only, and we are substituting the values. Xm is equal to mx1 plus mx2 by m1, that is m plus m. Okay, students, it is m of x1 plus x2 by 2m. Okay, students, then mm get cancelled. Xcm is equal to x1 plus x2 by 2. Okay, it is the mean distance between the two bodies. In this way, you can find out the center of mass of a two-body system, students. Then what about a number of bodies which are in the plane? Here we have the solution, students. We can do it very easily. I hope you are following the class. Let's say is a plane. Okay, students, I'm taking a two-dimensional plane. Obviously it is the x-axis and it is the y, is the origin. Let's say particles are situated at various positions. Okay, students, it has a mass of m1, say it got a mass of m2, and it is m3, and number of particles are distributed in this plane. We have to locate the position vector, students. Let's say it is r1 bar and it is r2 bar, and we have one more x, it is r3 bar, and so on. Okay, so students, in this situation, how to find out the center of mass? Okay, here center of mass R, okay, can be written as sigma m1 r1 by sigma m1. Okay, students, or it can be written as R bar Cm is equal to m1 r1 bar plus m2 r2 bar plus m3 r3 bar, okay, by m1 plus m2 plus m3. Okay, students, if there is n bodies, you can write plus 1. Here also we go with the same. Okay, students, here if R is resolved into the components Rx I cap plus Ry j cap plus Rz k cap, in this case we can write center of mass along the x-axis Xm. I am writing the coordinates m1 x1 plus m2 x2 plus m3 x3 plus 1 upon m1 plus m2 plus m3 plus 1. In the same way, YCM, coordinates of y-axis, is equal to m1 y1 plus m2 y2 plus m3 y3 plus so on by m1 plus m2 plus m3 plus so on, students. Similarly, ZCM is equal to m1 z1 plus m2 z2 plus m3 z3 plus so on by m1 plus m2 plus m3 plus so on, where XCM, YCM and ZCM are the coordinates of center of mass of the system, students. Okay, students, I hope you would understand what is meant by the center of mass. Again, I am defining it as the point where the entire mass of the body is supposed to be concentrated. It is the introduction and also that derivation for the center of mass of a two-body system or n-body system, students. If you like the video, please subscribe my channel, and not only subscribing, forward my video to your friends also, students. Thank you for watching. Okay, students, let's do one problem. In case of the continuous mass distribution, or we call it as the continuous bodies. To do so, we are taking a rod, okay, students, which has a length of L and got a mass of M. Okay, to find the center of mass, we are taking a strip which has a thickness of dx and mass of dm. Okay, students, you have learned that position of the center of mass for continuous bodies is written as integration of derivative of mass into x by integration of derivative of mass. Okay, first we have to calculate this one. What is the derivative of mass? Derivative of mass is nothing but the total mass by total length multiplied with the thickness of strip or stretch what we took here. Then obviously it can be written as dm is equal to mass is m by L into dx. Okay, students, here m by L is known as linear mass density, students. Okay, and it is shown with the letter lambda. Then m by L can be replaced with lambda in the equation. Then the equation can be rewritten as xm is equal to integration of dm into x by m. Okay, by integrating the dm we will get the total mass. That's why I wrote in this way. Then it can be written as 1 by m integration of derivative of mass into x. Just replace derivative of mass with m by L. It is lambda, okay, dm is equal to lambda into dx, here lambda into dx into x. Okay, lambda is a constant, I am bringing it out, integration of x into dx. Okay, students, we have to find out the center of mass with respect to this axis. Is origin and the top, whereas the other end is situated at L. That means the limits are 0 to L, students. I am putting the limits as 0 to L. Okay, students, and you know that integration of x to the power of n into dx is equal to x to the power of n plus 1 by n plus 1 plus c. Here we are integrating x. Integration of x into dx is equal to x to the power of 1 plus 1. So 1 plus 1. It is x squared by 2. Now we are substituting this value with this relation. What we get? xm is equal to, okay, lambda by m and We integrated, that is x squared by 2 and the limit 0 to L. Here xm can also be written as lambda. Obviously know that it's m by L upon m. I am bringing out the 2 x squared and the limits of 0 to L, where m cancels. It is 1 by 2L into L square minus 0. We put the upper limit as L and lower limit as 0. Then what we have? It is 1 by 2L into L square, where L and square get cancelled. We get L by 2. Then location of the center of mass is L by 2. Okay students, it is the evidence for the center of mass of a body, for a regular shaped one, lies at the geometrical center. At the beginning we talk about that. If you need the further information, you can see the first video on center of mass. Okay students. Let's do one more problem on continuous mass distribution, students. This time we took a thin rod which is bent like a semi-circle, students. It is the rod, okay, and okay, obviously it is the radius, students. We have to find out the center of mass of this system by using the integration method, students. Okay, you know that xm is equal to integration of dm into x by integration of dm, and as well as ycm is equal to dm into x by y by integration of dm. Okay students, if you watch it carefully, it is the origin. That means what? Center of mass of the system along the x-axis is along this direction. That's why you can say the coordinate as 0. But what about what is that? Center of mass with respect to y-axis. Let's imagine a stretch is taken. Every time we are taking a stretch, okay students, okay, this stretch has a length of ds and with the mass of dm. Okay students, and see this, I'm connecting the stretch with the center of the circle. We get this angle, we call it as the d theta, and is the theta which is making me this. Actually it is very thin, almost these two are coinciding with each other. If you watch it carefully, we will get an arc here as the theta. It is the radius, and obviously it is radius. Okay students, from geometry you learn that angle is equal to length of arc upon length of radius. Is the angle, we are taking derivative of theta, is equal to length of arc. I told you it is derivative of s by radius. Okay students, then you can write ds is equal to r d theta. We related the radius, derivative of theta, and as well as the length of the strip as ds is equal to r d theta. Okay students, then after we have to find out the mass of this strip. Okay, as you learn that derivative of mass can be written as mass by length into dx. Okay, here we are taking dx as ds, then derivative of mass is equal to m by L into ds. But what is the length? In previous case, it is the rod. Then automatically we took length as L only, but it is bent in the shape of a, what is that, semicircular arc. And you know that the circumference of the circle is 2 pi r. Then this length L is equal to 2 pi r by 2. Okay, it is equal to pi r. Then mass can be had as derivative of m. Okay, m by pi r into ds. Okay, where m by pi r is areal mass density. Sorry, m by pi r is the linear mass density. Okay, students, here this equation, derivative of mass, I am taking it as the lambda only, is equal to lambda into ds. We have the ds, derivative of s, lambda into r into d theta. Derivative of mass is equal to lambda into r into d theta. Let's substitute. In the equation YCM is equal to integration of derivative of mass into y by capital M. It is 1 by m into integration of derivative of mass. We had lambda into r d theta into y. Okay, under the limits 0 to pi, students. We don't know the value of the y. Here we have to find out the value of the y. Y is the position of the strip along the y-axis. It is. Okay, students, now we are resolving this triangle into components. If this one hypotenuse is r, then it might be along the x-axis. Rx is equal to r cos theta, isn't it? And y component, ry is equal to r sin theta. Here this y is the component of r along the y-axis. We can write y is equal to r sin theta. Okay, students. See, students, we got the value of the y is equal to r sin theta. Okay. Now we are substituting the values in. YCM is equal to lambda, I am bringing it back out. Okay, lambda by m, 0 to pi into r d theta into r sin theta. Okay, students, then it can be written as YCM is equal to lambda by m r squared. These are the constants under the limit 0 to pi into sin theta into d theta. Okay, students, as you know that integration of sin theta into d theta is equal to minus cos theta. Okay, then it can be written as lambda r square by m minus of under the limits cos theta 0 to pi, and you know that pi is equal to 180, that is cos 180 is equal to minus 1. Then it can be written as lambda r squared by, okay, cos theta. That means what? Cos 180 minus cos 0. We took the limits 0 to pi. Okay, students. First we have to put the upper limit. That's why we got it as lower limit is 0. Okay, it is minus pi r squared by m into cos 180 minus 1 cos 0. Okay, 1. It is lambda r squared by m into 2. That is 2 lambda r squared by m. Okay, students, further it can be written as YCM is equal to 2r squared by m, and we are substituting the value of the lambda. Lambda we have, it is m by pi into r. Mm get cancelled and r squared, that is 2 by 2r by pi. It is the method to find the center of mass of a circular, semicircular thin rod, students. Students, in this video we are going to learn about how to do the problems in center of mass. Here the first problem goes like this, students. Was the board. Let's say it is a circular plate. Okay, students. The circular plate has uniform density. Okay, students, which has a radius of r. The problem goes like this. From this kind of circular plate, it has uniform density and as well as the uniform thickness. We will remove another circular plate from this, which has different radius when compared to this. Okay, he will ask you, what is the position of the center of mass? Or he will ask you, find the shift in center of mass. The problem goes in this way. If you watch the board carefully, you will find a circle there. Actually, I am representing a circular plate which has uniform thickness and as well as made of the same material, has the uniform density. Here is a circular plate. Let's say the radius of the circular plate is r, students. Okay, students, obviously it is equal to r. Here, imagine that we removed this portion from the circular. What's that? From the circular plate. Okay, he is asking us, what is the shift of the center of mass? And you learn that center of mass always shifts towards the heavier part. If you remove this portion from this, here, this is the portion what we are removing, students. Okay, it is the removed part. We are going to remove it. Okay, students, and it is the radius of the removed part. Means what? This distance is half of the radius. See this. This one is half of the radius, the circular part radius. Let's say this plate has a mass of m1. Obviously, it has a mass of m2. Okay, students. We have to find out the shift in center of mass. If you say it's the origin, and we learn that the center of mass of a regular shaped body is always located at the geometrical center only. Obviously, if we didn't remove this part from this, the coordinates of center of mass, either xcm or ycm, they are 0, 0 only. But what we are doing here, we are removing this mass. So obviously center of mass will be shifted. It is somewhere lies here. Then we have to find out the exact location. And you have learned that to find the center of mass, we have an equation. xcm is equal to m1 x1 plus m2 x2 upon m1 plus m2. Maybe observe the same thing in my previous video. Okay, center of mass of two body system. If you didn't watch it, please go and you will find. It is the center of mass for a two body system, students. Here we have to find out the mass. I said initially it has a mass of m1 and the removed portion has a mass of m2. Removed, we are taking it as the negative mass, students. It is a just assumption. You won't get any kind of negative masses, but to make the calculations easy, we are taking this mass as the m2. Okay, students, and he also saying that this material has uniform density. And you know that the relation between the mass and density. We are taking the thickness very small, that's why I am neglecting that term. And you know that density is equal to mass upon volume Okay, or density is equal to m by v. I am writing here, or m can be written as m is equal to rho v. Okay students, here m can also be written as rho into volume. Volume is what? Area into thickness here. Thickness is constant. That's why I am relating it as m is proportional to A. It is the constant, it is one more constant. A is the area of cross section. It is a circular plate, and you know that area is equal to pi r squared. Getting me, students? Means what we can write? The mass can also be written as pi into r square, where pi is another constant and mass is proportional to r square. Mass of the plate is directly proportional to the square of this radius. Okay students, see, I am taking it as the first mass. That means m1 must be written as m1 is proportional to r square, and I am taking the mass this one, that is m2 is proportional to, see, the radius of the plate is half of this one. I am writing it as r by 2 whole square. Okay students, we have the masses. Then after we have to take the positions, location of the particles x1 and x2. x1 is equal to 0. Just imagine the mass is not removed and its center of mass position is x1, that is O. And similarly we have to take the x2. x2, it is the distance. It is equal to r2, r by 2, sorry. It is r by 2. Just substitute the values in, students. We will get xcm is equal to m1 x1, m2 x2 upon m1 plus m2. In the place of m1 we are substituting r square, that is r squared into x1, it is 0, okay, plus m2, it is r squared upon 4. Okay, it is negative mass, I said. That's why I am writing it is r square by 4. I am considering it as the negative, and obviously it becomes as negative. Okay, into x2, it is r by 2. Here we have upon, okay students, m1 r square minus r square by 4, and it can also be written as minus r squared by 4 multiplied with the r by 2 by 3 mr squared by 4, where 4 get cancelled and r square get cancels, and what you get, it is minus r by 6. Okay, it is the shift in the center of mass. It might be somewhere. Okay, first it is here and it is shifted. Then what about the coordinates of center of mass with respect to the y-axis? As you know that ycm is equal to m1 y1 plus m2 y2 by m1 plus m2. Here we don't have any shift in y-axis. That's why the coordinates of center of mass with respect to y-axis is 0. Okay students, in this way you can calculate the center of mass, that means shift of center of mass. Let's do one more problem, students, which depends upon the same concept what you did right now. Here in this one, in this example, what I am taking, in example, let's take the radius which is equal to 6 centimeter. Okay students, and the removed part, you say it has the r1 and it is r2. r2 is equal to, as I told before, it is 3 centimeter. Okay, we have to find out the center of mass, students. Say this, xcm can be written as m1x1 minus m2x2 upon m1 minus m2. Okay students, we had to put the values there. Okay, we'll learn that m is proportional to r squared. That's why m1 is proportional to r1 square. 6 squared, 36. m2 is proportional to 3 squared. It is 9. Okay students, and also we have to take the x1 and x2. Obviously x1 is equal to 0 and x2 is equal to 3. It is a 3 centimeter. Just put the values there students. We will get xm is equal to m1. Okay, m1 is equal to how much? 36 multiplied 0 minus 9 into 3 by 36 minus 9 0 minus 27 by 36 minus 9 minus 27 by 27. Okay, 1 centimeter. The center of mass shifted to 1 centimeter right side, this left side students. And similarly, the YCM, there is no change in, it is equal to 0. In this way, you can find out what is that center of mass when a plate is removed from the circular plate of given radius. Let's do one more application students. In this one, in previous problem, we removed the circular plate which has the radius which is half of the radius of this circular plate students. Now, I am removing another plate from one of the edges. Okay students, here it is r by 2 and this entire length, it is also r by 2. Maybe the diagram is not well. Okay students, this portion we are removing. How the center of mass will change? Okay students, it is the r by 2 means what? This part is r by 4. Okay students. Okay, we have to use the same here. It is m1 and it is m2. Okay students, here it is r by 2 and it is r by 4. First we have to go with the same procedure what we followed there. Okay students, first we have to find out the mass. m1 is proportional to r squared we had. Okay, then we have to find out the m2. Okay, that is r by 4 whole square. m2 is proportional to r square by 16 students. Then after we have to find out the x1. x1 is equal to 0. Okay, then we have to find the x2. x2 might be equal to r by 2 plus up to here. This is the distance x2. Okay students, r by 4 it is 3r by 4 and remaining is easy students. Let us substitute the values. xm is equal to m1 x1 and the second mass is negative minus m2 x2 by m1 minus m2. Just substitute the values in. That is xm is equal to m1. m1 is proportional to r squared and x1 is 0 minus m2 is r squared by 16 into 3r by 4 upon m1 is r squared minus r squared by 16 it is minus r square by 16 into 3r by 4 divided by 16r squared. 15 r squared by 16. R square and r square 16 get cancelled, students. What we have? Minus 3r by 4 by 15. That is minus 3r by 60. Okay, students, 3 1s are 3 20s. That is minus r by 20. Okay, it moves here. Okay, students, similarly, you can find out the YCM as 0. It is the way to solve these kind of problems, whatever the position of the removed plate. Okay, students, let's see one more problem which is similar to this. Okay, I'm taking the same. I hope you followed this problem. Just we have to find out the masses, then the things will be easier for you. See the students here. It's a circular plate. Okay, students. Okay, this time what did happen? Another plate is removed from this, from its center exactly. Okay, students, this is the removed part. Then what would be the center of shift in center of mass? Shift in, there is no shift in center of mass. The coordinates of center of mass, xcm is equal to 0 and ycm is equal to 0. Since it is a ring, since when it is removed and it behaves like a ring, maybe it is r by 2 or anything, r by 4 or any. If you remove a part from the center, then it behaves like a ring, and you learn that there is no need of center of mass to be present in the at the center. That's why the geometrical center or the centroid is the center of mass of ring. That's why the coordinates of center of mass is equal to 0. Okay, students, let's do one more. See. Okay, students, this time instead of the circular plate, I am taking a sphere. Let's say it is a sphere which has the diameter of d and radius is r. Okay, students, it is the sphere. How do we find the center of mass? And you know that density, the same what I told before, the density is uniform, that is the d, and radius is r. Density is equal to mass upon volume. We said mass is equal to rho v. It is a sphere. You know that volume of the sphere is equal to 4 by 3 by r cube. Okay, students, here m can be written as rho into 4 by 3 by r cube, students, and mass is proportional to r cube. Okay, students, this is the relation when if we gave it as a sphere. The same story is happening. From this sphere, another sphere is removed from one of the edges. Okay, it has the radius which is equal to half of the radius of the sphere. Okay, students, now it turns into the first mass and it is the negative mass. Okay, students, then we have to find out the masses. m1 is proportional to r cube and m2 is proportional to r by 2 whole cube, since it is half. Then m2 is proportional to r cube by 8. Then after we have to find out is that x1 and x2. It is a center, geometrical center. x1 is equal to 0 and this distance is x2. x2 is equal to x1 is equal to 0 and x2 is equal to r by 2. Just substitute all the values in, students. What you get? We have the relation xcm is equal to m1 x1, negative mass it is m2 x2 upon m1 minus m2. Just we are substituting the values. xcm, m1 we have r cube into x1, obviously it is 0, minus m2 r cube by 8 into x2, it is equal to r by 2 by m1 r cube minus, okay, m is proportional to r cube, it is m2 r cube by 8, it is 0, minus r cube by 8 into r by 2 by 7 r cube by 8, and it can be written as minus r cube by 8 into r by 2 by 7 r cube by 8. Wait, 8 and r cube get cancelled, and what you get? It is minus r by 14. The shift in center of mass is minus r by 14. And what about the YCM? The same happened before. It is equal to 0. Here, if you put any numerical, r as 2 or 4 or anything, you will get the results in that way. My suggestion is, students, just remember, mass is directly proportional to the radius. Okay, the powers we are doing. If you take the circular plate, plate means what? Area is pi r squared, then it becomes m is proportional to r square. It is a sphere, and we have to take with respect to the volume, that is 4 by 3 pi r cube. That's why we took it is r cube. Okay, students, let's do one more example which is on the same concept. Here this time, instead of the plate, we took a square plate, students. Let's say the square plate has uniform thickness and made of the material of same density. Okay, as a square plate, students. Say is a square plate has a length of L and its breadth is also equal to L. What is saying in this problem? He is asking us, if a plate is removed is from one of its corners, okay, here in this way, this is the removed mass. Okay, this is removed, which has a length of half of the length of the plate and breadth which is half of the length. Then he is asking us, what is the shift in center of mass? I hope you understood. It is a square plate, students, which has thickness T. It is made of material of uniform thickness, and as well as it has the uniform density. Its length is L and its breadth is L, since it's a square plate. And a plate is removed from this. It is from one of the edges. Either it is from here or here or here or here, anywhere. He is asking us how the center of mass will shift. First we have to locate the center of mass. Obviously it is, before we removing, a geometrical center is the center of mass. As you know that for regular shaped bodies, center of mass is a geometrical center only. That's why we took the coordinates as x1 is equal to 0 and as well as y1 is equal to 0. Okay, students, then after we remove the portion from this one, then how? Okay, the center of mass will change, we have to find. Okay, students, it is the line which is passing. I'm not good in drawing. Okay, actually, okay, I have to take it as like this, and everything is fine now. Say it is A, it is the B, it is a C, and it is the D. Okay, students, here its center of mass obviously at the geometrical center only. Let's say, okay, it is O dash, and it is O dash and O dash. Okay, students, see, we have to find out. We took x1 as equal to O, and we need to find x2. x2 is O dash. Okay, students, but we don't know the value of the O dash, this length. Okay, here it is a right angle triangle. What's this? Okay, in that triangle we can write dB squared is equal to hypotenuse adjacent AD squared plus, say it is B AB squared, and substitute the values. dB squared is equal to AD squared, it is L square plus L square, it is 2L squared, and dB is equal to root of 2L square, that is L root 2. We have this entire length is equal to dB. Then see, it is the half of the length, and it is passing, it is 1/4. O dash is 1/4 part of the dB. Okay, students, then we measured it as O dash is equal to L root 2/4. Okay, that is, we got O dash as L root 2/4. Let's take the mass first. This one, after removing, say it is a m1 and it is m2. m1 is directly proportional to area L squared, and m2 we have to find is proportional to, see this, L/2 and L/2. L/2 whole square, that is m2 is proportional to L squared by 4. Okay, students, we had m1 and as well as the m2 and x1 and x2. Next we have to substitute the values in. Then we get xcm, as you know that it is m1 x1 plus m2 x2 by m1 plus m2. Okay, students, or it can be written as xcm is equal to m1 x1 minus m2 x2. We are considering the removed mass as the -1. Okay, students, by m1 minus m2, that is m1 we had is L square, and x1 it is 0 minus m2 L square by 4 into x2, what we have, L root 2/4 by m1 L square minus L square by 4. It is minus L square by 4 into L root 2/4 by 3L squared by 4. For 4 and L square get cancelled. What we have, students, it is minus L root 2 by 4, these are 12. Okay, students, it is xcm. In this way you can find out the center of mass, and similarly you will get the ycm also. It is equal to 0. If you put the numericals in, and you will get the result. Okay, if you want to do, just put a numerical, and do remember this. Those who are going for the competitive examinations have to remember this equation. Simply will get the answer, and maybe the question will be asked from the center it is removed. Obviously you have to say the center of mass is 0 itself. This plate, instead of here from the middle they removed. How the center of mass will change? The simple, it remains there only, since it is a regular shaped body. Here we are taking one more example, students, and this time we are taking a rectangular plate. It is the rectangular okay, students, this rectangular plate has a length of L and breadth of B. Before we did a problem in the case of a square plate, just dimensions have been changed, and it has the uniform density and as well as has the same thickness. And from this portion is removed, students. Okay, this is removed, which has the length which is equal to L by 2 and it is equal to B by 2. Okay students, we are writing with respect to L and B now. And as you know that before, what is that, we removed this portion, the center of mass lies at geometrical center, then you can write the coordinates as x1 is equal to 0 and y1 is equal to 0. Here the same thing will happen. Once again, the center of mass always shifts towards the heavier mass. Okay, in this case. Okay students. Okay, and if you take this one, it is a rectangular plate, it shifts towards the heavier mass. Let's name it as AB, C, D as the center, and the center of mass shifts here, say it is O dash. Again we have to find out what is that x2. It is x2 students, it is x1. x2 is equal to O dash again. Okay, and y2 is obviously it is equal to 0. Getting me students? Then we have to write the mass. Know that mass is directly proportional to area. That's why m1 is proportional to lb. Okay students, and m2 this is the m1 and m2, it goes with the same ratio, L by 2 into B by 2, LB by 4. Okay students, we had, and just we had to substitute in the relation XCM is equal to m1 x1 plus m2 x2 upon m1 by m1 plus m2. Since it is the negative mass, as a positive we are putting the signs. XCM is equal to m1 x1 minus m2 x2 by m1 plus m2. Okay, and we need to find the O dash. Okay students, this is m1 minus m2. Okay, in this rectangle we get a triangle here, that is dv square can be written as what, dA square plus AB square. Same procedure we are following. It's the length and it's the breadth. dA is the breadth, B square plus L square. That is dB is equal to under root of L square plus B square. Okay students, and we need to find out the O dash. Obviously it is fourth part of that. O dash is equal to dB by 4. It is root of L square plus B squared by 4. Okay, and you know that it is equal to x2. Just we are substituting the values in. What we get, XCM is equal to m1. m1 we had, it is LB into 0 minus LB by 4. Okay students, into x2 we had under root of L square B plus B squared by 4 by m1 LB minus LB by 4. It is minus LB by 4 into root of L square plus B square by 4 divided by 3LB by 4. Okay students, where 4 get cancelled and LB. It is minus under root of L square plus B squared by 12. Okay students, in this way you can find out. Let's check it's whether it's right or wrong. If you consider it as a square plate, then what you get, L is equal to B, L square plus B squared. Okay, 2L square, L root 2 by 12. Okay, same results we will get. L, where if see L is equal to B, then it turns into a square plate, then what you get? Under root of L square plus AL square by 12. It is minus root of 2L square, that is minus L root 2 by 12. The same result what you did before. I hope you understood how to solve these kind of problems. Students, we are doing the example center of mass. Welcome to NQuest Physics students. Previously it is known as Quest Head of Physics. Okay, today we are going to do one more problem which is on center of mass. Here you see it is a lamina. What's the lamina? It is? It's a thin plate. That too, it is a thin flat plate. Thin flat plate is known as a lamina. That too, it is a regular lamina. Watch it. Let's go with the dimensions of this lamina to understand the things very easily. I'm taking it is one of the block and it is another thin plate. Actually, is the first thin plate and second kept one over other. Let's say it has a length of L that is equal to 2 meter. I am taking numericals. Okay, students, and its breadth, take it as 1 meter. Okay, students, in the same way, it is the breadth of the second plate. It's of 1 meter, and its length, say it is L2. It is equal to 1 meter. Obviously, it would be 1, and it is what? 2, 1. These are the two plates. Let's say they have the masses of M1 and M2 respectively. Is a problem, students. He is asking us find the center of mass of the system with respect to O. Here I am locating O here. It is. We have to find out the coordinates of center of mass with respect to this. As usual, you know that center of mass can be had as XCM is equal to M1 x1 plus M2 x2 upon M1 plus M2, and similarly YCM is equal to M1 x1 Y1 plus M2 Y2 upon M1 plus M2. It's a two-body system. First, what we have to do? First, we have to locate the center of mass of the two plates. Okay, students, where it lies. Okay, we have to locate the geometrical center. Since they are regular shaped bodies, what's the joining the chord? What's that? Diagonals. And here is the centroid. Okay, students, in this case we have the same. Extend this. There is the diagonal. There's one more. Okay, it is a centroid. By help of these two centroids, we have to find the coordinate, students. Let's say it is a coordinate. These are the x1 and y1, and for this x2 comma y2. Okay, students, here this length is obviously equal to x1 through the center here, and here it is y1. Getting me, students? Similarly, x2, see what I am doing. It is x2, and here up to here it is y2. Okay, students, let's find the magnitudes of x1, y1, and as well as the x2, y2. x1, see, it is the geometrical center. The length is 2 meter. It means here this distance, half of the total length is the x1. That is x1 is equal to L1 by 2, and you get 2 by 2. It is equal to 1. It is 1 meter. Okay, students. Similarly, we have to find out the y1. y1 is equal to b1 by 2. Is the b1 1 meter, 1 by 2. It is half meter. Okay. And we have to find out x2. See this? It is the x2. Okay, this distance. That means what? x2 is equal to x1 by fourth part of this. See this? Okay. x1 is equal to how much? No. Fourth part of the L1. This one. Half part of the x1. That is 2 by 4. It is 1 by 2 meter. Okay, students. And y2. y2, this one. It is 1 meter and it is half meter. 1 plus half. It is 3 by 2 meter. Okay, students, we have the coordinates x1, x2 and as well as the y1 and y2. Then after we have to go with the masses. It is the first block I said. If you watch it carefully, mass is directly proportional to area since it is a thin plate. That means you can write m1 is proportional to a1, okay, and m2 is proportional to a2. a2 is the area of this plate. a1 is the area of this one. Then what we had? m1 is proportional to a1, means area of this 2 into 1, 2 square meter, and a2 is equal to m2 is proportional to a2, this one, 1 into 1, it is 1 square meter. Okay, we had the areas and as well as the masses. Then just we are putting the values in. That is xm is equal to m1 x1 plus m2 x2 by m1 plus m2. Let's put the values. xm is equal to m1 we had, it is 2 units into x1 into 1 plus m2. Here we have got it is 1, and x2 here it is 1 by 2 plus 1 plus 2. It is 2 plus half by 3. Okay, it is 5 by 2 by 3. It is 5 by 6 meter. In this way you can calculate the coordinates of center of mass xcm as the 5 by 6 meter. And similarly you have to go with the ycm. ycm is equal to m1 y1 plus m2 y2 by m1 plus m2. m1 obviously here we have it is 2. At y1 we got it is 1 by 2 plus m2 it is 1, and y2 is equal to 3 by 2 by 1 plus 2. It is 2 by 2 plus 3 by 2 by 3. Okay, students, 2 by 2 1 plus 3 by 2 by 3, 2 5 by 2, okay, by 3. Okay, students, these are the coordinates of center of mass xcm and as well as the ycm. In this way we can solve these kind of problems. Okay, students, let's do one more problem. Here this time we took a lamina which is in the C shape. Okay, let us see. It is made of 3 rectangular flat frames, that is a 1, is a 2 and is a 3. Okay, let they have the masses of m1, m2 and as well as the m3. Okay, students, they have the dimensions 2 meter, 1 meter. This area you know that. Similarly it has 2 in 1 and it is 2. Okay, it is a 2 meter. We have to find out the center of mass with respect to one axis. It is, as usual, you know that the coordinates can be had as xcm and as well as the ycm. Let's say it is the 1. Okay, we are locating the coordinates. It is geometrical center, and obviously it is x1. Okay, the same thing goes with this also. Okay, students, it is x2. Okay, and it is x1. I told you x1 is equal to x2, that is equal to 1 meter. Okay, students, and similarly we have to find out the y1. It is y1, it is half meter. Okay, and if you go with this, the geometrical center, then it is, that's the x3, isn't it? It is x2. x2 is equal to half meter. Okay, students, then we have to go with the y2. y2 is equal to, it is 1 plus 1, 2 meter. And similarly we need to find the y3. It is y3. Okay, students, it is 1 plus 2, 3 and half. 3 and half means what? 7 by 2 meter. And we have to find out the masses. It is 2 into 1. m1 is equal to m2. It is equal to, what you get is directly proportional to area, 2. Okay, students, 2 units, you can take it as the kg, and this one 2 into 1. Okay, m3 is equal to 2 units. Just substituting the values in, what you get, xcm is equal to m1, x1 plus m2, x2 plus m3 x3 by m1 plus m2 plus m3. Put the values m1, m2. Okay, all have the same masses, that is m of x1 plus x2 plus x3 by 3m. mm get cancelled. Okay, students, x1, what we have? x1 is equal to x3 is equal to 1. 1 plus half plus 1 by 3. It is 2 plus half by 3. It is 5 by 6 meter. Okay, students. Similarly, we will get the YCM. YCM is equal to m1 y1 plus m2 y2 plus m3 y3 by m1 plus m2 plus m3. That is, mass is same, m of y1 plus y2 plus y3 by 3m, where mm get cancelled, that is y1 plus y2 plus y3 by 3. Let's take y1. y1 is equal to half. Okay, half plus y2, 1 plus 1, 2 meter, plus y3, 1 plus 2, 3, 3 and a half means 7 by 2 by 3. Okay, okay, students, it is 24 by 4 by 3. It is 8 by 3 meter. In this way, you can find out the XCM and YCM as 5 by 6 and 8 by 3 meter. Okay, students. Here's the method to find out the center of mass of three-body system. Here, by using the same method, you can find the different structure, students. Let's do one more problem in center of mass, students. Here in this problem, it is a structure which is made of 3 blocks. It's a 1, 2 and 3. Let's name this block is 1, it is 2 and it is 3. Okay students, we have to find out the center of mass of this block with respect to the origin which is kept here. Okay students, let's say the length of this entire base is 4 meter. You can take any value, and similarly say it is the same, it is 4 meter. Maybe they look weird and say this length is 1 meter and it is 2 meter and it is 1 meter. Obviously, let's take this height of this block is equal to 1 meter. Okay students. Okay students, here we consider these blocks as 1, 2 and 3. And as usual, the center of mass of the three body system along the x-axis can be written as xcm is equal to m1 x1 plus m2 x2 plus m3 x3 upon m1 plus m2 plus m3. And similarly, ycm can be had with the same notations, m3 y3 m1 plus m2 plus m3. First of all, we have to find out the masses and as well as the positions. As you have learned before, mass is directly proportional to area. Since the density of the material is constant, okay, you know that density is equal to mass by area, areal density. That is, mass can be written as, okay, in this way, mass is proportional to area. Let's take this one. We have to find out the mass of this structure. It is the length is equal to 1 and breadth is 4. Let's say it is m1. m1 is proportional to 4 into 1. Okay, 4 units. Okay students, in the same way we have to find out the m2. m2 is proportional to, we are just using the same 2 meter into 1 meter. 2 into 1, it is 2 units. Obviously, m3 also has the same value of the first one, 1 into 4. Okay students, 4 units. We know the masses. Okay students, m1 is equal to 4, m2 is equal to 2 and m3 is equal to 4 units. Let's find is that position of the particles, that means what, bodies with respect to the origin. If you take this block, okay, see this, we have to find out the geometrical center. Obviously, it is geometrical center. Okay students, and it represents the y1. Okay students, and this part, this distance is x1. If you watch it carefully, it is totally 1. Then x1 is equal to 1 by 2 meter, and we get the y1. Since the length is 4, this height is 4 and y1 is equal to half of that, it is 2 meter. We had the coordinates x1 and y1. Similarly, we have to go with this and locate its geometrical center. Okay, here I have to do the same thing in this way. I have to locate, this is a geometrical center. Here also it is a geometrical center and it is height. Okay, obviously if you say it is y2 is equal to, the total height is 1, here I showed, it is equal to 1 by 2 meter. And we need to find the x2. Often we confuse it over. Maybe it is the x2, but not. Here from the origin you have to measure. It is 1 plus the total length is 2 plus 1. Means what? 1 plus 1. Okay, it is equal to 2 units. We had the x2 and y2. And finally we need to find the x3. Okay students. Here the same thing is happened. Okay. And if you go with this and join the diagonals, the met at a particular point, it is the same as y1, it is y3, obviously it is 2 meter, and here measure this, it is half, it is 1 plus 2 plus half, 3 and half, okay, means 7 by 2 meter, and y3 is opposite, it is 2 meter. We got the values of the coordinates, that is x1, y1, x2, y2 and x3, y3. Just it is a substitution. Then put the values in. xcm is equal to m1 x1 plus m2 x2 plus m3 x3 by m1 plus m2 plus m3, and take the value of the m1. m1 is 4 and we are taking the x1, it is 1 by 2, and m2 2, and we had the x2, it is somewhere into 2 plus m3, here we have it is 4 into x3, already we got it 7 by 2 by 4 plus 2 plus 4, it is 2 plus 4 to 1s to 2s plus 14 by 4 plus 2 plus 4, 18 plus 20, 6, 10, it is 2 meter. Okay students, in the same way we have to find out the YCM. It is m1 y1 plus m2 y2 plus m3 y3 by m1 plus m2 plus m3. We call it as the YCM students. Let's substitute the values. m1 obviously it is 4, and take the y1 we have here, it is 2 meter plus m2 is equal to 2, and y2 we had y2, it is half plus m3, same as that, by m1 means what? 4 plus 2 plus 4, here 2 to get cancelled, it is 8 plus 1 plus 8 by 10, 17 by 10 is 1.7 meter. In this way you can find out the center of mass of the U-shaped body. We did few examples of that, and I hope you understood how to calculate the center of mass of a thin lamina. Okay students, in next part of the video we are going to do the problems in center of mass of continuous body. That means what? We will do some little bit of integration. Okay, with that we will find the center of mass of various structures like thin rods. It seems like with respect to one axis it seems like this. It is a thin rod. Okay, we have to find the center of mass with respect to any position. Let's say it is L and M. We'll go through that one. In the same way, we will find the center of mass of a thin rod which is bent in the shape of a semicircle, and also we find the center of mass of thin plates. It is the plate. Here, in next part of the video, we are going to learn about these kind of structures, students. If you like my videos, please subscribe my channel and forward the channel to your friends. Okay, and my suggestion, students, watch the videos till and then you can understand the topic very well. Thank you for watching my channel.